Okay. Hi. Good afternoon, everyone. My name is Sidharth, and I have my colleague Uluk joining online. And we're here today representing RTL Germany. And we're here to talk to you about our journey building our content knowledge graph. Yeah. Um, but before I get to the knowledge graph itself, I wanted to give you a bit of background into RTL and specifically RTL Plus. RTL Plus is a streaming platform that is one of the largest in Germany. And what is unique about RTL Plus is that we're not just a video platform, but really bundling together content like audiobooks, music, podcast, and soon magazines. That's the way we like to think about it. Is it's like one subscription to rule them all, right? This presents unique challenges and opportunities that come with it, and that's really the inspiration for us building the knowledge graph. You can imagine the discovery problem, right? So how do you know what the consumer wants to consume next? When you are within a particular purpose, so let's say video, and let's say you watched the Harry Potter movie with your kids at home, then the next recommendation is most likely going to be the next chapter in the Harry book series, or maybe The Lord of the Rings, or maybe Chronicles of Narnia. So there is a very narrow scope, and you clearly know what is likely to be consumed next. But given our scope and given the vast variety of content that we offer, it could very well have been a Harry Potter fan podcast. It could very well have been the Harry Potter audiobooks. You don't really know, and you would like to give the user the option to choose and select. That's our motivation. That's our inspiration to move towards the content knowledge graph. So you see an example here from actual content that we host. You see movies. You see like a movie like Chef, which is to do about street food and cooking and so on. You have also articles from, again, a cooking magazine that we own. This one being about empanadas. We have a podcast that we host. Again, here, this particular episode is talking about street food. And there are also shows that we run with popular celebrity chefs in Germany. How do you bring all of these together? You also need to have enriched metadata, and you also need this to be put into a taxonomy that allows you to link everything together. For example, here, Karl Casper is the name of the chef in the movie Chef. And at the same time, the name of the chef who is in the show that we also run is Tim Melzer. So getting all of these together to say, hey, this is an entity and this entity is a chef, and bringing that together gives you the pathway towards building those recommenders, which is where the knowledge graph comes in. So that's basically to say, or the inspiration of the starting point for our content knowledge graph journey. How did we go about doing it? So at the beginning, so that's the first phase, we don't really know if it's going to work. It's an idea in our brains. We kind of see examples of it across companies that we saw here as well. But we also don't want to go ahead and build this huge monolith, because building a knowledge graph, as we heard in an earlier talk, is quite high in terms of barrier to entry. You need to set up a lot of things and so on. So we prefer to follow a more hacky solution, I would like to say. So the tech stack was Apache Iena to start with. So open source solution, already available, comes with its own, I would say, query layer. So with SparkQL on top of it, so already set up and good to go. When we come to the pipeline part itself, you do need to extract entities. So how do we go about doing that? In our particular case, this was not so easy to just simply work around it, because we're talking about German celebrities, and that's not so easy. So we started off with custom. So we started off with the German language BERT model, and then adapted it for named entity recognition. And then for named entity disambiguation, here we try to be a little creative and use the Google Analyze Entities API, which gives you back what you call an MID. So that's actually Google's internal knowledge graph ID, and also a link to the Wikipedia URL. So this was like a cheap way to kind of work around the whole disambiguation problem. And then, of course, we try to restrict the data sources that we're working with. So we work with only some of the purposes and not all. So that would mean we focus on video plus audiobooks or video plus magazines. So not really exploding the problem to a large space. And at the same time, we also look at only structured data. So what does that mean? If there is an actor or a director column that's explicitly identified in the metadata, then we would go ahead with that. We are not looking to extract additional metadata from the text in the form of NER and stuff like that. So these were kind of steps that we took to limit it so that we are still fast in building it to show the value and at the same time proving the concept. What were the results? We basically established that there is value in doing something like this. There were a couple of things that came out. For example, searching for competitive content on our search engine. If you look for something that's on a different streamer on our platform, you obviously don't find it, but you can find content that's similar to it. And that's because it is linked in the knowledge graph via the wiki ID, via the external source, and so on. We also found content clusters, which again was insightful and probably gives us a hint of where users might roam around in their exploration. So definitely valuable, definitely interesting insights. But we also came across several challenges. Challenges primarily around adaptability. So this was being built in the knowledge graph team, so like a separate standalone team, and working with, at that time, the search team, a separate team that's responsible for the search experience, and the recommendations team, again, responsible for building recommenders. And the biggest pain point was, hey, how do I access this? Do I need to write a SparkQL query? Oh, that's so complicated. I know SQL, but this is a whole other beast. Don't you have a simple REST API that I can use? Yeah, fair enough. The search team, hi, we need sub-millisecond responses. Is that possible? Unfortunately not. Performance was one of our biggest issues with making use of Apache Iena. And then, of course, data quality. You discover things only when you work with the data. So things like genres all across the place. So that's really something that you only know of when you start combining these data sets together. So yes, comes with its fair share of problems, but at the same time, there was value and there was interest in this. So we then decided to move forward to the next phase. And this is where I would say we're looking to build something stable, long-term, and a more production-oriented approach. Again, that's the goal, but we want to do it in an iterative fashion. So still being quick, still being fast to prove some, let's say, wins, right? So you want to see wins rather than spending a year building this out. And the way we did this, of course, is focusing on some of the things. The most important thing for us was the content that we're dealing with and the entities that we have in them. So RTL has a lot of reality TV. So reality TV includes a lot of German celebrities, maybe not as well known internationally, so not so common in Wikidata or Wikipedia or any of those sources. So we definitely had to build something custom. So we had a custom NER and now also an NED model. On the tech stack, we decided to move to AWS Neptune. So that's our graph database. And we decided to use Plumba. Not sure if many of you heard of it, but it's a tool that allows you to orchestrate Jupyter notebooks. Why were we doing this? Because all the NER, NED models were in Jupyter notebooks, and we wanted to find a very quick way of just chaining them together to get to our knowledge graph, dump it in AWS Neptune so you can get going. In hindsight, maybe not the best decision. We are currently looking to change that to Airflow or a proper orchestration tool. But yeah, again, that was the trade-off between getting something out there and kind of building it well. And the last thing that we really focused on was adaptability. So we wanted people to adapt the solution. And to do that, we had to build a REST API. We even also built a Python package. Again, why we do this is so that our customer teams like search, like recommendations, who are again predominantly Python teams, can easily adapt this into their workflow, into their notebook. And that's again the benefit that we were looking to get. What did we learn from this phase? The biggest learning from here was that we needed to set up an in-house annotation team or a team of experts combined with students who could help us validate what our models were telling us. This was very important, as I said, because we have very, very local content. And so it's important to have that native knowledge, that native information, so that when the NER model says, hey, these are the bunch of 3 celebrities who have been detected, we need to know whether that's actually accurate. Then we need to add it to the database. And the next time that we see it in another piece of text, it gets disambiguated. And then again, we have human in the loop to check whether the disambiguation happened correctly. So all of this was very new to us. Because it really needs a lot more planning and effort to put up this team and so on. But we could see the benefits of having an intelligence or a human in the loop in this kind of fashion. The other big learning in this case was adapting the ontology. So again, we borrowed heavily from the Wikidata media ontology, and it was really a great starting point, and we wanted to stick to it as much as possible. A couple of areas where we really needed to make this adaptation was one around genres. So rock is a genre of music, but is it a genre of movies? Not really. And so we needed to adapt the ontology in a way that we are reflecting individual purpose-based genres, but at the same time having some kind of cross-purpose genre tags so that you are able to build recommenders based on that. So that's an example of how we had to adapt the ontology in this case. But more importantly, we had a lot of surprising discoveries, and I think this is really the part that that I want to share with you, that I really enjoyed, which is suddenly now editors starting asking for access to it. Right? They're like, hey, okay, this is pretty cool. Can I start playing around with this? And what did they want to do? They wanted to use this to explore the content, right? So they know of some things in the back of their mind. So for example, I don't know, Mother's Day is coming up, or maybe just passed, and they want to create a teaser row in the app for Mother's Day. So with movies and audiobooks that are around the theme of family and love. And of course, they know a lot of these content pieces inherently. It's just things that you and I know. A Christmas movie is Home Alone, for example. But there are a lot of other movies in the catalog that they just don't know, or once they know it, I mean, once they see it, then they know it, but otherwise they don't, right? So this is really their use case. A program planner, so these are people in linear television who decide which show goes in which slot, really enjoyed the competitive intelligence that we were able to provide, because they know what show competes with what show and could, plan the schedule accordingly. And probably the most surprising, and or maybe I shouldn't be surprised that I was surprised then, because I heard in the keynote today talking about data silos, and that's precisely what we saw. There were multiple teams from across the organization reaching out to us and saying, hey, we have this data source and we want to join it to this other data source, but there is no common ID, although the content is the same. Or maybe the content is the same, but slightly misspelled or kind of phrased differently and so on. So very soon we found ourselves becoming pseudo source of truth because of the disambiguation process that we had done. So what I wanted to say is that although we built it for the RTL Plus use case to power search and to power recommendations in a programmatic fashion, what turned out is that there are applications much beyond that, and applications that are not necessarily purely to do with content itself, as we see in the case of acting as a single source of truth. So where are we now? So this is kind of now looking forward. We have kind of tried to beef up our pipeline, make it more production oriented, and serve multiple use cases. An example of that is the screenshot that you see on the right, which is the content exploration tool. This is really a content exploration tool, free-form text search, filtering and faceting by different genres, talent, and so on. So really something that editors across RTL are able to use. But even more importantly, and something that I think we want to really pursue going forward, is marrying behavioral data or user data with the content data. This is something that is being explored, or that we have explored just in the last couple of months, where what we're trying to do is we have a lot of first-party data at RTL. So we know households, we know what they have viewed, and you can now match that with the content knowledge graph to create very, very targeted, refined, and fine-grained user segments. So a user segment is something like, I don't know, DIY lovers. Now, there is a certain definition and there is a certain number of people that belong here, but that segment is missing a lot of people who watch DIY shows on television because they cannot be mapped to the content knowledge graph. So by making use of the content knowledge graph, we are able to increase the reach of these segments. Again, a completely different use case to what we imagine, and has potentially very, very high uplift potential for the organization. So, of course, there are a bunch of other, I would say, side effects or products that we are still supporting. Definitely search and recommendations as our primary use case, but also the models that we developed, like the NER and so on, are used also as standalone APIs by other teams as well. So, to conclude, what I wanted to say is that we started on this journey maybe 2 years ago. I was not even at RTL, so I joined RTL maybe 3 months after we started this. And till that time, the only experience that I had with Knowledge Graph was because I had written a chapter in my book on NER and NED. So that was my my limitation. But yeah, in the 2 years since, we have really gone through this journey and made a lot of mistakes, and also didn't know a lot. So that's also what I wanted to say. But we put ourselves out there. So within the organization, we were always talking about the knowledge graph, which then gave us all these use cases and kind of broadened the scope of what we did. And what we are here for today is also a very similar endeavor. The idea is to just put it out there and share it with this great community, and hopefully we get some ideas. So just earlier today, I already got some ideas and connections on ontology and designing ontology. So exactly the reason why we're here. And yeah, kind of looking for ideas on how you would marry a user knowledge graph with a content knowledge graph, and yeah, maybe listen to some experience around that. So yeah, thanks a lot for your time, for listening in, and I'm happy to have any questions.
Any questions? I'm curious about the, you mentioned the behavioral data. Is that all like viewing data, and does it span like all the podcasts, all the different media you mentioned? Or?
No, it doesn't. So it's you have different kinds of behavioral data. The one behavioral data is what comes from households. So it's a completely different data set that you would track separately and so on. So again, it's not even at the person level or an individual level, but rather at the level of a household. And you basically have what program did a household watch from when to when. And then what we do is disambiguate the program name with our content knowledge graph, and then enrich that with all that information, which then helps build better segments. That's basically what we're working on now. But the other one that you're referring to probably is the actual click data, tracking data from the app itself. And that's kind of what we're still in the process of integrating. This is where we don't really have a very clear idea yet on how to do it, because do we take an extract from the content knowledge graph and then marry it by building a separate user knowledge graph and stuff like this? So this is, I would say, still very explorative. But this data exists, and it exists for all purposes. But that's also the challenge on how do you integrate.
You did infer correctly what I was going to ask, but also you reminded me of another question of, is the household the relevant unit, or do you have like I know like Netflix, for example, it's like individuals can have accounts.
Yeah, so the household is the one for the specific use case that comes from the advertising area. So this is actually not even related to the app. So it's completely separate, almost like third-party tracking, and then you get your own first-party data from that and stuff like this. But at the user, so for the app itself, we have at the user level, so user account level, so not even at the household level. So you have much more fine-grained tracking data at that level.
I enjoyed the hints about your journey with Wikidata through the talk, and I just wondered if you could talk a bit about your strategy for using it. So I'm just thinking about, for instance, MPs, or you alluded to how much did you go anticipating what you would need, or were you lazy loading at the time of annotation? And maybe just be interested to hear a bit about your strategy for how you used it.
I will maybe ask Ulukbek, maybe if he can.
Yeah, sure. I could jump in here probably. Hi, everyone. I'm Ulukbek, the data scientist in the Knowledge Graph team. So how we went about using Wikidata was twofold. First, Wikidata was in the beginning, our inspiration point for building up our ontology, because as we know, when we are starting out building the ontology from completely scratch for a very custom use case, then there are a lot of questions about the hierarchy, about the naming conventions, and so on and so forth. So Wikidata was our inspiration point. Second, Wikidata was one of the two knowledge graphs, along with the Google knowledge graph, and a target knowledge graph to conduct disaggregation against. So we used Wikidata QIDs as IDs for initial disaggregation, especially in phase 1. And once we had those IDs, we could also use Wikidata as an enrichment point for pulling out aliases, for example, for pulling images and additional relations of interest that are contained already in our ontology. So these are the use cases where Wikidata came really in handy.
Maybe this slipped past my attention, but from phase 1 to phase 2, I saw that you moved your graph database from Jenna to Neptune. Can you talk a little bit more about why you made that shift?
Yeah, so I can maybe give an intro, and then Ulugh, maybe you can jump in a bit. So I think with Apache Yena, we were really running into scaling issues. So things like we were running it completely on our own. So it's not really managed. It is a team of 5 people. So it's also not have the DevOps expertise or what you have. And at that point, we get into an evaluation exercise to see, okay, which are the commercial options managed, then supported, and stuff like this. And there were a couple of options that we ended up with. And AWS Neptune was the way we chose to go, simply because there was some experience in the team before that. The team from AWS kind of worked us together. RTL also has a historical relationship with them, and so on. But maybe Ulugh can jump in with a bit more of the technical details.
Yeah, absolutely. So first of all, after we realized the shortcomings of Jena that were prohibitive for us to go forward with, we started exploring enterprise knowledge graph database solutions, basically. We came up with a list of requirements, among which fast response times, graph machine learning capabilities, and so on were of importance for us. And after conducting our comparative analysis, contacting the vendors, we came to a conclusion that AWS Neptune would offer us a good combination of price, performance, and features for the use case. So we made our decision to go forward with AWS.
Sounds good. Shameless plug. I'm with dgraph Labs, which is another graph database, which is why I ask. But thank you.
Mm-hmm. Cool.
Any other questions? Anyone else? All right, well, thanks so much, Sidharth.
Thank you. Excellent.